Now we're moving on to something new. To date, we've been focused on building web applications, so-called server-rendered applications, which generate the user experience in the server using the handlebars, templating engine, and other tools. This has served us reasonably well for the moment, but we're about to take a step now into something a little bit different. And this is the whole world of client-side JavaScript applications. Perhaps I'll start by a little demo and we'll just get a sense of what's going on here. This is familiar to you now, donation. I seem to be able to select an amount, select a payment method, a candidate, and press donate. But you'll notice what's happening here is a little bit different from what we've had to date. First of all, notice that as I change payment methods here, something is happening to this button or this label. Same thing is happening down here. And also notice that I press this button, this is updating here immediately. Also, this application is not running on a server. It's entirely in the client. I have not launched Donation Web Server. I'm just running a separate project, which we'll be starting to build from this week. And the first week or two will have no interaction with Donation Web at all. It'll all be taking place in the client itself. So this is new. We probably could have seen something like this weeks ago when we started experimenting with jQuery. You could imagine you'd install event handlers on buttons, change the DOM to reflect a table being extended here, or to reflect different buttons being selected. There's no jQuery at all in this application. In fact, the application itself is quite sparse and quite easy to understand, in fact, once we get into it. The application I'm showing you, the website I'm showing you, if we call it that, is built using the Aurelia framework. It's well worth taking a look at aurelia.io. This 5-minute video is a very good introduction. And then the guides section here is really good. Particularly the overview, which gives you good background as to what Aurelia is, technical benefits and business advantages. But also the documentation is quite superb really in terms of taking you into the application framework itself and how it works. 2 good tutorials here, and then there's a range of examples and discussions around these major topics. Fundamentals, binding, which is something we'll be looking at fairly early on, and then into templating, routing, plugins, integration, and so on. So let's get started. We're going to look at introducing Aurelia, then we're going to look at a walk through the lab, effectively what you'll be doing in the lab here, the Lab Aurelia 1, and then we'll see how we get on at the end of that. Okay, starting with introduction to Aurelia and giving us a general context. Talk a little bit about SPAs, what that means, web components in general, and then we'll get on to Aurelia. SPA stands for single page application. You may have heard of it. It's a term that's been around for a while. It's a term that is very much in the realm of client-side frameworks. We could say client-side frameworks allow us to build SPAs. By single page, we mean one page is delivered to the browser, and then all interaction in the browser is handled by the framework, dynamically modifying, updating, laying out multiple views. But all these views are rendered client-side. They're not, or do not require interaction with the server. We could have simulated or implemented this using Ajax jQuery features, but they quickly become very challenging to implement using jQuery. jQuery is quite a low-level technology. The noticeable thing about the client-side frameworks is MVC makes a reappearance. We discussed MVC weeks ago, and you've seen it in other frameworks as well. While MVC, or variants of it, particularly things called MVVM, model, view model, make a reappearance in the client in these frameworks. Also, the work we've been doing to build up a REST API starts to pay off now, because not only are you building possibly Android applications interacting with it, but we would also build interactions with our service from our JavaScript client using the same REST backend you've been building. Key features, they don't care what the backend is. So we've built the backend in Node, obviously, so it's quite seamless, and it's going to be fairly straightforward to perform our interaction because we'll be exchanging JSON, but it could be written in anything else. The apps are very often data-driven and event-driven. That is, things happen, we update things. We're less concerned with imperative command and control, relying exclusively on submit buttons, as we would have been with the server rendered applications. We could get better performance using these frameworks. That is, there's not as much network traffic. There may be an initial load time, but once we're loaded, a lot of work can take place in the client with occasional interactions with the server, and very rarely full page refreshes. If cleverly implemented, it can enhance the user experience. So the notion of moving from page to page can start to fade away, and we're in what effectively is a rich environment. Obviously, we're decoupling our client and our server here. We've already been building the tests for the server, so we can start to continue to enhance those as we expand the API. And we can start to evolve a separate set of tests on the client. Now, Aurelia comes with a comprehensive end-to-end testing framework. We won't get time to look at that, but it might be worth looking at once you've completed our introduction. It also potentially gives us something easier to build and maintain. The reason for this is that if we were to attempt this similar complexity using jQuery, we would have a lot of work to do. The frameworks ideally provide us with fairly high-level abstractions that let us evolve sophisticated apps reasonably quickly. The heavy JavaScript lifting on the client, well, a lighter backend. Well, the backend now becomes totally focused on the API. We could even strip out the server rendered application if we wanted. We'll leave it in position there for the moment. Also, these frameworks potentially offer easier offline operation. So if the application is in the cache and it can be loaded, maybe it'll keep chugging along even if the network becomes unavailable for periods. This is something that server rendered really can't cope with. So what does the performance mean? Well, if we're in an SPA, one load, everything comes down once, and from then on we're just using AJAX requests behind the scenes. The server then, particularly the server templating engine, is not all the time grinding on delivering new pages for each request. And remember, we could be talking hundreds or thousands or hundreds of thousands of users. We're just delivering a load initially, and then the load on the server is fairly light. You've seen how SPAs have raised the bar for user expectations. The card carrying demo of this is probably Gmail, which everybody used. It's extensively based around very sophisticated client-side JavaScript. But of course, many other applications used on a day-to-day basis now are also recast as SPAs. Any of the social media sites, particularly Facebook, for instance, would be SPAs or pretty close to being a small number of pages, but a very sophisticated range of interaction. So this is where some user expectations are at, and delivering a server rendered application to match those expectations would be quite challenging. SPA frameworks give us significant power to be able to match what the user has come to expect. Now, it's not the only game in town. There's an emerging standard called Web Components. Worth having a quick peek at it if you get a chance. A good few conferences and publications the last year or so, and a good few tools. This is evolving, I would say, on a parallel track to SPAs in general. So a little bit of tension here as to how they overlap, but there is evidence that they're starting to converge. Google is playing a very strong role in web components. They've actually released a range of components already called Polymer, and they've released a catalog, in fact, of Polymer components. It's worth having a look around. These seem to embody reusable client-side components we can plug into either server-rendered or SPA applications. And the component standard is emerging and stabilizing fairly fast. They're evolving, thinking around custom elements, standardizing templating. So this would mean we could be less obsessed with handlebars or Jade or Pug or whatever. And then the whole world of HTML imports, which means splitting up our HTML client side into multiple components, and the shadow DOM. DOM manipulation and DOM updating is known to be a challenge, particularly in terms of efficiently manipulating DOMs. And shadow DOM is a technology whereby a separate DOM can be maintained in the browser, updated independently, and then merged with the primary rendered DOM. It's not quite as simple as that, but the idea is that we can perform very fast updates to the DOM using shadow DOM techniques. We're not really going to be looking at Polymer, nor are we going to be learning about web components. But we will be talking about web components, and as you delve into the Aurelia documentation or any other frameworks, they will be starting to talk more about components as time goes on. And some of these components are quite compelling. This is from the Google catalog. There's a calendar component. You can see what that might do, a chart, an analytics component, and so on. Generally, these are packaged up and made independent, encapsulated pieces of functionality we can incorporate into our web client side. Google Map component, for instance, you've already maybe experimented a little bit with that. This component does a good bit more. So, components aside, what's Aurelia? Client-side framework for mobile, desktop, and web. Powerful and simple conventions, and it's got a set of values or principles that are worth reviewing here, and see if we can start to evolve our understanding and motivation for using the framework. So I'm going to go through each of these very briefly, just to give us a general context. First of all, forward thinking. It's written in what they are calling ES Next, and you'll see this in the generator when you get into it in the lab today. Their name for ES Next, what they mean by ES Next is the next versions of JavaScript that are coming down the line, whatever they are. So it tries to stay on or slightly ahead of the latest approved standards. They do call out web components, so although that standard is still emerging, they're promising support early. No external dependencies, that's interesting. Particularly no jQuery or no other JavaScript libraries. This is a little bit unusual because many of the other frameworks require a host of other libraries that again have their own versioning and management issues. Leveraging technology of the future. So the idea is to build applications that are using future standards but that work with existing browsers. Data binding is something we already saw in action. You saw me experimenting and clicking on buttons and somehow things were happening immediately. This is not imperatively done. I'm not writing event handlers in here and poking at DOM elements to change them. It's happening automatically via data binding. That is, the application framework is designed with automatic synchronization between various model elements, such that an update of one immediately is reflected in maybe an appearance change in another. We don't have to code that, we just have to declare that, and we'll see that shortly. Now the router makes a reappearance here. We've been using routers quite a while now on our server, a router for the API, a router for our server rendered application. Well, all of the SPA frameworks introduce client-side routing technology. Same basic idea, URL paths leading to different views, except this is all in the browser and not routes delivered out to our REST API, for instance. We won't be looking at routers immediately, but we'll see them in action in a few labs' time. The language, as we know, is evolving pretty fast now in recent years. 2015, 16, 17, 18, they're all rolling on. And a very significant entrance into this world is TypeScript. Some of the SPAs are starting to support TypeScript explicitly. TypeScript is compatible with JavaScript, but introduces stronger typing and also brings forward features from future JavaScript into JavaScript now, renamed as TypeScript. We won't be using this, at least not initially. We're going to stick with the ES Next, as they're calling it. But you'll see when we generate our first app, we have an option to generate TypeScript if you want. And the TypeScript experience is very nice. It's highly recommended. But I think it's probably easier for us to stick with JavaScript for the moment. The architecture is modern. You'll see a strong emphasis on decoupled components, and then how those components can be assembled to work in specific contexts. So we'll be able to get up and running without learning a vast API, but rather by acquiring knowledge of smaller, fine-grained entities that we can integrate. Now, the notion of custom elements is tied to web components, and the web components is an evolving standard, at the heart of which is the idea of a reusable thing or component to be incorporated into any page. And those components are delivered as new elements, tags if you like, a calendar tag or a map tag that we just include and populate as if it's any other tag, but of course it expands out into a dramatically enhanced range of functionality. Aurelia supports this standard and invites us to think about creating components or elements that deliver serious functionality. The framework embodies the MV star pattern. So you're familiar with MVC, Model View Controller. Well, that's just one of a suite of patterns in user interface design. And among the more appropriate client-side versions of MV star is MVVM, Model View View Model. And we'll see that in action shortly. Quite testable. What we mean by that is that we can write unit tests to test the components independently. Particularly, we can test the JavaScript classes independent of perhaps the HTML that may be attached to them. You'll see this in action if you explore the Aurelia test approach. We could be writing Mocha tests or related that will be stimulating and exercising the client-side classes we build and making sure they're robust and performant and so on. Okay, that's a general intro. Let's now, in the next talk, start to think about how we would start to build a simple application. And we'll tour through effectively what you'll be doing in the lab.